All right, 6.8 ready. This is what we're going to work on in class today, Tuesday, March, whatever it is. And basically they're giving us a review of one concept and, well, really a review of two concepts. But the way they introduce it, it makes it a bit confusing because now all of a sudden you're seeing a decimal inside the triangle. Don't let that confuse you. All right? And I'm going to show my work, and I'll show you how little the work is. Focus on the interior angles first. We need to focus on that, and then we need to focus on sides. So let's talk about interior angles, and then we'll talk about sides. All right? If we focus on the interior angles, we know that all of those angles add up to 180 degrees. So I have one that's 90, I have one that's 68.2, and I have one that's A. So plus A is equal to 180 degrees. Now I know that. So I can go through and I can add 90 and 68 plus A, and I can show my work that way. I could do that. And in fact, let's go ahead and do that right away, and then I'll show you a little bit of a shortcut. Let's see, 90, because teacher don't add too good in his head, so 2, 8, and it's 15. So 158.2 plus A equals 180, and then we're going to subtract 158.2. Again, this is where the calculator is helpful to you. Okay, so 158.2 minus 180. I gotta borrow 7, 10, 9, 10, 8, something, 0.8, 1, 21.8. Okay, we do this old school. Now, the shortcut to this is already knowing that one of these angles is 90 and taking that away at the beginning. So really what you have is you have A is equivalent to 90 plus A equals 90, excuse me, not 90 plus A. You have 68.2 plus A. Because remember, these two angles here have to add up to 90 degrees. 90 degrees is already spoken for. So I took away the 90 at the beginning, essentially is what I did. So the value of A is going to be equal to this problem right here. If I know that, then why can't I just say 90 minus 68.2 equals A at the beginning? Why can't I just do that? I mean, that's sufficient enough work. This, you're looking at complementary angles. And then we would go ahead and say A is 21.8. And I want to make sure I label that, 21.8. Always label your triangle when you're done, all right? Now we want to focus on sides. So again, you can do one of these two, all right? I'm showing you both avenues. Multiple ways to solve problems. Sides, now I want to focus on the sides. Well, you have one leg is 5, another leg is 2, and the other side is n. You just have to remember, decide which. It's a right triangle. I know 2 of the 3 sides. Yes, you use Pythag. What is Pythag? Pythag is if I take the legs and square them and add them together. So 5 squared plus 2 squared is equal to the hypotenuse squared. I can't stress that enough. We've gone over and over and over and over and over and over that. Right? Yes, the formula is A squared plus B squared equals C squared, where A and B are the legs, C is the hypotenuse. So 5 squared, 25, 2 squared is 4, equals n squared, 29 is equal to n squared, and you go, oh no, what do I do at this point? Well, what you do at this point is, you got to get n by itself. So I've got to go from n squared to n. How do I do that? I take the square root of both sides. So the square root of 29. So yes, your answer is a decimal. That's essentially what that's saying. My answer is a decimal. The square root of 29. Well, I don't know what the square root of 29 is, Mr. Wilson. That doesn't make sense. It's not 29. Think about the square root of, think about square roots. Square root of 4 is 2. Square root of, what's the next perfect square? Well, 5. 5 squared is 25. Okay, so the square root of 25 is 5. What's next? Actually, I take that back. If we take 3 and square it, we get 9. So 4n squared, I get 16. 5n squared, I get 25. How silly of me to forget about all those in between. 29 is still more than this, right? What if we take 6n squared? We get 36, right? So it falls somewhere in between, but probably closer to 5. So that square root of 29 that we're talking about is approximately my little squiggly equal sign. That was kind of bad. The little squiggly equal sign means approximate. This is going to be probably what, 5.2 or 5.3, somewhere around in there. Now, is that a reasonable length for this hypotenuse? Yes, because the hypotenuse has to be longer than the longest leg. All right? And again, in this, we need to go back and we need to identify. In fact, that gives me an idea. I'm going to change the directions on you. You need to identify what these are. Leg, leg, hypotenuse. You need to do that for all 6 of those. All right? Or actually all 5, because you only have 5 to do now, because we did 6. There's your example. Make sure you show your work, and make sure you label the sides accordingly.